All right, today we're going to move on and find out how to find square roots of larger numbers by using an algorithm. By the way, an algorithm is just another name for a shortcut. Like the way that we divide with does McDonald's constantly sell cheeseburgers in that 5-step process, that's an algorithm for long division. So there is an algorithm for finding square roots. All right. By the way, speaking of finding square roots, 2 people have sent in their homework from yesterday, the skills test 1 through 9. Both of them got 100. Okay, I just hope that everybody is doing the work. I know James Roniger is, because he sent me a picture of the work that he did along with his answers. Excuse me. But you don't need to send the work with you now. You just better make sure you have the work with you when you come back to school, because I will be checking it. All you have to do now is fill out the answer sheet and then send that back on Google Classroom. All right. So again, what we want to do is talk about, on your homework, number 9 was a very hard one to do guess and check for. It was 314,721. All right, and again, if you're going to do this with guess and check, it's really pretty difficult with guess and check. All right, because if I wanted to find out what it's between, it's not between any of those that I gave you yesterday through 90 or even through 100. Because remember, 100 squared was 1 squared with double the zeros would be 4 zeros. That's only 10,000. This is way larger than that. So 200 squared would be 40,000, because 2 squared is 4 with 4 zeros. 300 squared would be 90,000. Still not even close to here. 400 squared is 1,600,000. I'm sorry, 160,000. Double the 4 is 16 with 4 zeros behind it. 500 squared is 250,000. I'm getting closer now, but I'm still not there. And then 600 squared would be 360,000 rather. So your answer is going to be somewhere in between, in here, somewhere in between 500 and 600. All right, but there's a lot of things in between 500 and 600. So it's going to be 500 and something, and then it ends in a 1. So the only numbers that when you multiply times themselves end in a 1 is 1. So it's going to be 500 and something 1 or 500 and something 9. Because 9 times 9 ends in a 1, 81 ends in a 1, and 1 times 1 is 1, ends in a 1. So it's going to be 500 and something 1 or 500 and something 9. But there's a lot of somethings in there. It could be 501, 509, 511, 519, all the way up to 591 and 599. So that's going to take a long time to guess, okay? Now you can make it kind of by looking, where is this located? 314,000, is it closer to 500, which is 250,000, or closer to 600 squared, which is 360,000? Well, it's actually sort of in the middle, but a little closer to this one than to that one. So maybe you could try a little closer, maybe 571, but then you'd have to square 571, which is not hard, but it's a pain. All right. All right, I'm trying to do this fast, but you would have had to do it. And again, don't do it too fast, because it might be the right answer and you might multiply wrong. But regardless, I think I put too many 5s there. 5 times 7 is 35, carry a 3. 25 and 3 is 28. So when I add this up, I want to make sure I don't go too fast and mess it up. It turns out that 331,000 is too big, okay? And it's about 50,000 too big. So now I have to go down into the 60s. Now I could go down to 561 or 569. And again, if I don't want to make sure I don't skip over, I go to 569 times 569, 81 carry your 8. That would be 54 and 8 is 62 carry your 6. That would be 45 and 6 is 51. Put a 0 here. 6 times 9 is 54, carry you 5. 6 times 6 is 36 and 5 is 41, carry you 4. 6 times 5 is 30 and 4 is 34. Put 2 zeros here. 5 times 9 is 45, carry you 4. 5 times 6 is 30 and 4 is 34, carry you 3. 5 times 5 is 25 and 3, again, is 28. And again, when I add, my answer is too big. But now it's getting pretty darn close. So now, I'd be willing to bet that the right answer is 561, because it was close enough that I can't see it going down further than that, but you always got to check. 165, put a 0 here, that's 6, 36 carry you 3, 33. Put 2 zeros here, 5, 30 carry you 3, there's that 28 again. And again, that's a 1, 12 carry you 1, that's 6, 12, 17 carry you 1, 4, that's 11 carry you 1, 3. Ding, 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 ding. It took me 3 guesses and a lot of multiplying, but I could get it with guess and check. And again, you go, oh my God, do I have to do that all the time? Well, believe it or not, when I first started teaching 40 years ago, that's the way I taught it to do all the time, okay? And the truth is, when I was telling you about Ethan Bauer's teacher expecting him to do it, that's the way Ethan Bauer's teacher expected him to do it at Jesuit, all right? And it turns out, way back when I first started teaching, okay, I taught a boy named Joe Gagliano. And I remember after he left Our Lady of Divine Providence, where I taught, and he went to St. Charles Borromeo for high school, he came one day to pick up his little sister at school, and I saw him, and he was in the car with his mom to pick up his little sister. And he said, I want to tell you thank you, because what you taught me in high school really helped a lot, in grammar school really helped me a lot for high school. And of course I was young and pretty cocky, and I said, well, thank you, and I was pretty proud of myself. And he said, but there's one thing you didn't teach me that I needed to know. And I got really defensive and said, I don't think so, Joe. I think you just weren't paying attention that day. He goes, no, really, there's something that you taught. I said, well, what was it, so I can make sure I teach it? He goes, how to find square roots of really large numbers. And I said, Joe, I taught you that, you just weren't paying attention. Remember, I told you pick a number, the guess and check, okay, and you narrow it down till you get to the right one. He goes, yeah, I remember you teaching us that, but there's a much easier way. And I said, I don't think there's an easier way. Again, I was kind of cocky. And I said, I don't think so. So I said, I really want you to come show me. So he came upstairs, and I gave him a number, the perfect square, and said, okay, show me it. And he started to do something, he couldn't figure it out. So he said, no, Mr. Dew, I can't remember what it is, but I promise you there's a way to do this. And I go, I don't think so, Joe. I think the only way to do it is with guess and check. Again, I was kind of conceited and cocky. Anyway, he left that day and said, I'm going to go home and find out how to do it, and I'll come back tomorrow and show you how to do it. I said, okay, Joe, but I don't think there's another way. So anyway, that night I went and visited a friend of mine, the smartest man I think I've ever known. Okay, and we were sitting around talking, and while I was talking to him, I said to him, Wayne, have you ever heard of a shortcut way to find square roots of big numbers? Shows you how nerdy I am. I'm talking about that when I'm visiting with a friend. But he thought for me, he said, no, I only know one way. And he turned around and he did something that really kind of blew my mind, because I had never seen it before, okay? And I said, whoa, wait, explain this to me. So he went step by step with me, and it turns out it was this algorithm. By the way, the next day, Joe showed back up, and sure enough, he started to show me how to do it. And I said, Joe, you were right, I was wrong. There is another way to do it. And he and I did it together. And I said, from now on, I'll teach your way. By the way, I call this Josarian's algorithm because Joe Gagliano is the one who taught it to me. But the truth is, it was around a long time ago before Joe showed it to me. But anyway, I'm going to show it to you right now, okay? And you need to pay very close attention because at first it doesn't seem to make sense. But if you really grasp it, then all of a sudden it becomes more sense. It's sort of like when we change repeating decimals to fractions. When you first did it, it was very hard. But as you did more of them, it got easier. But I really, really recommend that you write down, okay, what, excuse me, what the process is as we go. By the way, I will be sending you a copy of the algorithm that I pulled off online, but somehow I think it's easier if you copy the examples I show you. This is part 1, and I'll be doing part 2 in a minute because I know it's going to take too long because I talk too much.